So first things first, we're going to talk notation. Okay. Inverse function, f inverse, or f inverse of x. That's how you read that, f inverse. It looks like a little exponent of -1, right? When we write it in function notation like this, we don't actually mean like do any math over there. Okay, so remember, it's just a notation to tell us not the original f, but the inverse of f. Does anybody recall from Algebra 2 how to find an inverse? Dylan.
Switch out the y and x.
I love it. Switch x and y, yes. It could be in a table of values, like a t table. You got a column for x, you got a column for y. So to find the inverse, you just switch them around. It could be on a graph. If you've got ordered pairs, x, y, then the x becomes the y and the y becomes the x, and you graph it in point. It could be in an equation, where you see like y equals 3x plus 5. Then you write x equals 3y plus 5. Solve for y. So no matter what you're working with, the idea is still the same, switch x and y. In the realm of pre-calculus, remember we've been talking a lot about domain and sometimes range. So domain is all the x's, range is all the y's. What happens when you switch x and y to make an inverse to your domain and range? They also switch, right? So I would make an extra note that we're going to be paying careful attention to, and that is our domain and range also switch. So the domain of the original function becomes the range of your inverse function. The range of the original function becomes the domain of your inverse function. And when I do domain and range, I oftentimes, while I could do it down at the end in the inverse, I oftentimes go back to the original just in case I'm ever in that issue like we kind of talked about yesterday in compositions where g of x was affecting our composition domain. Sometimes the original function can affect the domain of our inverse function. And so I usually go back to the original and take a peek at that. Does anybody recall how to verify inverses? What is the process to verify inverses algebraically? What do you test? What do you mean plug it in and see if they equal one another? Yeah, okay, so that's one method to like rewrite it again, to redo the inverse and see if you get back to the original. But there is some other check that we would use. Sean? Something like that, maybe. It has to do with our combinations of functions from yesterday. Composition. Do you remember what the composition is supposed to equal? Close, 1x. The only thing that will remain in a composition of a function and its inverse is x. So to verify inverses algebraically, we would do a composition f of inverse of f of x, and that must simplify to be 1x. If there's anything else in that composition, then it's not an inverse. And we talked about this last year as well. Not only do you do f of f inverse, but you should also check that f inverse of f is also x. So one thing that maybe if you practice with your compositions, you'll notice is compositions are not commutative. It doesn't turn out to be the same depending on the order. It can change up. So in order to be inverses, both directions have to give you x. And that's kind of like what happens, like we set them equal to, and you're thinking like everything's going to go away. So the operations are going to undo each other. The only thing that remains is x. Good. Next slide, we're just going to talk real quickly about what an inverse means visually. So visually, when we're talking about inverses, when you see a function and its inverse, the inverse, because you just switched x and y, the inverse is a reflection over the line y equals x. So you said x and y were the same thing, they were equal, because you switched them around, and then that results in a reflection over that line. So the graph of f inverse is a reflection of the graph of x in the line y equals x. And I'm going to draw a function, and then we'll do the inverse function just to kind of see how you could draw the graph of an inverse function if you were given the graph. I'm going to pick a graph that's from your pink sheet, your basic functions. It's the cubic function. And the cubic function has a point at -1, -1, 0, 0, 1, 1. And then it's got that bend in the middle. It's not really a turn, and then change direction, it just bends a little bit. And I'm going to call that my f of x. If you have the picture and then you're asked to draw a picture of the inverse, what I would do first is draw the line y equals x. And then reflect the image over that line. Now, if you're actually working on like a graph, a coordinate plane, you've got grid marks, things like that, you could pick out specific points, x, y ordered pairs, and you could switch the x and the y and plot a new point. In this case, I don't really have much other than my 3 points I plotted, and they're not much help because they're on the line y equals x. So I'm just going to use sort of visual sight here and reflect. And I'm actually, on this one, I get a better graph if I do it in the middle first. So I've got this little piece that's curved right here, and it's above the line y equals x. When it reflects over the line y equals x, it'll be below. So it'll look something like this. And then this one is below the line y equals x. So when it reflects, it'll be above the line y equals x. And then these points, all these points on this piece over here that's extending towards positive infinity, they're going to reflect on the other side an equal distance. Pretty difficult to draw 5 points, but it's going to look something like that. And they're going to start to get further away from the line y equals x. And then over here, the same thing will happen. So this would be my inverse function. Now I have the inverse function over here on the sideboard. That original function was the cubic function, x cubed, and the inverse to a cubic function is a cube root function. So this parent function should look familiar to you even though it's not on the pink sheet. Do you agree with that? You studied this? This you learned when you did square root. Square root was the one that starts at 0, 0 and then just is the little bump up. Okay, but the cube root, you can do odd roots of negative numbers, so it extends forever in both directions. So this would also be another graph, like you should know the parent graph of this, and you should be comfortable with that. Does anybody have any questions about how to draw an inverse given a picture? Pretty basic. Two question. Okay, that's probably not my best drawing, but it'll do. Next up, we got 2 things to talk about, then we'll look at some examples. First one is horizontal line test. Sorry, trying to get that fixed. This is worded really funny. If no horizontal line intersects the graph at more than one point. is also the same as saying a horizontal line can cross at most 1 point, right? It's really the same rule as vertical line, yeah. Okay, but it is worded a little bit funny, so be aware of that. If no horizontal line crosses the graph of f at more than 1 point, then f has an inverse function. Now, the word function there is really our key word. If a horizontal line were to cross at more than 1 point, the graph would have an inverse, but it wouldn't be a function. And we're concerned only with inverse functions today. So if your graph doesn't pass the horizontal line test, you don't have to find the inverse function. There is a when a graph can pass both tests, the vertical line test and the horizontal line test, so it's a function and its inverse is a function, that's a very special function. It's called one-to-one. One-to-one means not only does every x have exactly one y, every y has exactly one x. So both things are true. Function implies every x has one y. And one-to-one implies also every y has one x. So neither the x nor the y repeat. So in your homework assignment, the book is going to ask you to do things with inverse functions. You need a one-to-one function in order to be able to do the work. Okay, so you'll do the horizontal line test. Let's look at a couple of examples, and then I'll give you some time to work in a small group and try an example. We're going to do finding the inverse, and then we're going to look at that stating the domain and range. Okay. So I'm going to do this one with you really quickly. F of x equals the square root of x plus 1. Remember that f of x is a fancy way to write y, so this is really just y equals the square root of x plus 1. And Dylan had told us at the very beginning to find an inverse we would swap out x and y. So we can write x equals the square root of y plus 1. Oh, I suppose I should do my horizontal line test first. Make sure I should keep going, right? What does a square root function look like? Like a little arc, like a little hill, like a little bump. And this one has been moved to the left one. Does that pass the horizontal line? Yes. So it has an inverse function. I should continue. So I switch to x and y. How will you solve for y here? Square both sides. Good. Got to get rid of that square root. So you have x squared equals y plus 1. Then you're going to subtract 1 from both sides, so you get x squared minus 1. I'm going to go ahead, and this side would be y, but this is now my inverse, so I'm going to use my inverse notation. F inverse of x is equal to x squared minus 1. What does this graph look like?
Parabola.
A parabola that has been moved down 1 because it's after the x squared. Okay. Now, if I reflect this graph, the original graph, the square root graph, over the line y equals x, am I going to get a parabola? No, I'm only going to get half of a parabola, right? I'm going to get something that looks like that. That's going to be my inverse. So this is one where it would be a good idea to think about domain and range, not of your new function, but of your original function. So looking at the black graph, what's the domain of this square root function? Where does x start? Negative 1. And it includes -1. You're at -1 comma 0. So -1 to infinity. What's the range of that square root function? 0 to infinity, and it includes 0 because that's a point on the x-axis. And so remember what we said, when we switch x and y, we're just going to switch the domain and the range. So down here we'll say the domain is really the 0 to positive infinity, and the range is -1 to infinity. And this range would agree with the quadratic, what Cole was saying, it's a parabola that's moved down 1. That would be true even if we had the whole parabola. But notice, because we looked back at the original function, we see that we don't want the whole parabola, we only want half of the parabola. Does the domain from 0 to infinity correspond with that reflection? Yeah, it starts at 0 and goes to the right. So, one thing you can add to your inverse function is a statement x is greater than or equal to 0. So you've seen that on functions before, like in your Algebra 2 textbook. They would be like, find the inverse of this function, and it would give you a function like a quadratic, but it would say, comma, x is greater than or equal to 0. And a lot of people probably ask their math teacher, what am I supposed to do with that? Nothing. Right? It was just trying to say, like, it's not the whole parabola, it's just part of it. Find the inverse. So this helps you say only half of the parabola. Any questions on that one? Okay, what are you thinking about for this next graph? F of x equals quantity x plus 1 squared. It's going to be a parabola that is moved left 1. Does that pass your horizontal line test? No. No inverse function. It's a little exciting. Move on to the next problem. So if it doesn't pass the horizontal line test, there is no inverse function. You can't do that piece. If I had given you this and put a comma right there and said for x is greater than or equal to -1, then we'd be looking only at one arm of the parabola, and that would pass the vertical line test, or sorry, horizontal line test. So if there's a restriction that makes it 1-to-1, then you'd be okay. Now, I'm going to give you a little bit of time, probably till about 2:25? So you don't have a lot of time here. I'm going to say 2:15-ish. And what I really want you to concentrate on your groups is not the domain and range. We can talk about that as a whole fairly quickly. But I want you just to kind of brainstorm, can you write the inverse function? And I'll tell you, both of those pass the horizontal line test. That first one is the cube root, passes the horizontal line test. And then this one over here is that rational function. It's like the reciprocal function on your pink sheet. So it passes the horizontal line test. Okay. So go ahead and take a few minutes with your group, and you can talk it out and work through some steps together. See what you can get in ways of just writing the inverse. Okay, what can you get done? You need to sign out at the door. I told one person in every group that I agreed with their inverse, so if you got an answer, make sure you check with that person that you have the same answer. And then move on to the second one. I don't
Well, you know what Fran said? Instead of just like, I could do that tonight, so we're just gonna tap down instead of keep playing with it. Because I say, because you can open that and do that one. Like, the tap down, like, that's terrible. Yeah. Or just like,
Yeah. Alright. Actually, I can know. I can
I don't know if you guys know, but like, it's like, we're just walking in the field. I'm so nervous. I like, and I'll find
Hopefully it's not the same guy that was like, how they explained it. Yeah. That's what you do in class. There's one positive thing there that you
There's so many positive things that happen.
Dad.
Yes, definitely.
Hopefully he's not dropping.
I don't know why dad can do that. I have him in class. I'm not gonna say my name wrong. I don't know what I'm doing. Or I'm scared that like I'm gonna mess up everything. Not even the dance. I don't care if it's dance.
Wait, like
Yeah, just like everything. Also, what I did is I jumped on accident.
Well,
I didn't realize that was like 3, 4, 5.
When you decided
well, isn't that like what
We
you're
were
supposed to do?
just like
not, so if
Yeah,
you
like-
decided to solve, then you haven't solved for why on why it's on the other side.
Bro, I love it when Benster's it's like
So you have trouble with.
like it's so powerful. I love it.
But we were gonna do that like it's like 1, 2.
You don't know if you're
God,
like,
we're punching and jumping.
oh, you do.
But then it's like but it was really cool. Imagine that. I definitely had not been in problem at all.
No,
Yeah.
you would need 2 equations to be
Yeah.
able to do elimination. Okay, I'm going to call our attention back to the front so we can talk about a few things. I started each one just in the very basic sense of f of x is really just y, and then I'm switching x and y. And I went by each group and we were all doing an excellent job with this very first one. Tell me the steps that you're going to do to solve for y. Cube it. And subtract 7. So there's your inverse function, x cubed minus 7. Now we should talk about domain and range. Okay? And I told you, don't worry about that. When you look at this cube root function, and that's like the one that we did in the drawing the inverse from a graph, what's the domain of the cube root? Negative infinity to positive infinity, right? This side goes to the left, and that side goes to the right. So domain is negative infinity to positive infinity. What's the range? Negative infinity to positive infinity. So the cubes and the cube roots are actually very easy. If when I switch those, they're really just the same things, right? So domain and range on here should be negative infinity to positive infinity for both. And that's because the cube root has that same set of domain and range. There doesn't need to be any kind of restriction here because that S shape or that snake shape will just reflect all of itself over to the other side, and you won't have the issue we had with the parabola. Okay, on this one, some people were on the right track, and I said, I like what you're doing so far. So if I said that to you, what's the thing I said, what did you do to start it? Yeah, okay, you have this issue of having something in the denominator, and how are you going to solve if you've got y in the numerator and the denominator? Get it out of the denominator, so multiply both sides by y, okay? That at least gets rid of y in the denominator. Now, on this side you have y plus 2 times x. And if you don't distribute it, the only thing you'll ever be able to do is divide the y plus 2 back to the other side, which gets you right back where you started. So to make something new happen, we're going to have to distribute. Okay, so that we get terms and not two factors over there. So xy plus 2x equals 5 minus y. Okay, and some people got to that point too, and I said, I like where you're at right now. And when I saw people who had that, I said, you just need to refocus. What are you trying to do? Solve for y. Where do you see y? xy and on the other side as a negative y. So when you have the variable you're trying to solve for, and it's on the left and the right side of the equation, you want it to be on the same side. So you could write in the margins of your notebook to give yourself a hint here, get y on the same side. Right? That's what we're going to do. So I'm going to add y to the other side. xy plus y. And then I'm going to subtract 2x because it doesn't have a y, so I don't need it over there. You okay with that? Okay. Get y on the same side. That's what you would do if you had just x's and numbers and x was on both sides. Get x on the same side and you try to get all the numbers on the other side. Now, xy plus y is not helpful. Can't add them together. And you can't divide by y because then you're going to have to divide by y on the other side and that's not going to solve for y. So, you have two things that are being added together. What do they have in common? Y. So you can factor out a y. Okay, so there could be two little hints you're writing to yourself in the margins of your notebook. Get y on the same side first. Everything else that doesn't have a y on the other side. And then, if all the terms on one side have y's in them, you can factor out y. Now how will you solve for y? Divide. So when you do the inverse of what I would call a rational function, you get another rational function. Okay, questions about what I did? We should still talk about domain and range. Now, I'm going to go back up to the original, just because I think looking at the original can be really helpful, okay, especially if you're doing the square root and it turns into a quadratic kind of thing.
All the even powers and stuff like that?
Yes, all the even powers.
And just even powers?
Yes, because the even powers all kind of look like parabolas, only the quadratic is actually a parabola. They're all U-shaped, and the odd powers all look like the S.
And odd powers you can plug in negative numbers, that's the reason.
Odd powers you can plug in the negative numbers. Yeah. Okay, now you got to do a little stretch down memory lane. The last chapter of Algebra 2, rational functions. When you're talking about domain, every rational function is going to have a vertical asymptote here. Vertical asymptote is whatever makes the denominator equal 0. So what value makes the denominator equal 0? Negative 2. So this domain would be everything except for negative 2. And you can write that down. Domain, set the denominator equal to 0. Exclude that value. Alright, range. Those reciprocal functions, if you look back at your pink sheet, they have a vertical asymptote and they have a horizontal asymptote. In this chapter 1, finding the horizontal asymptote, we'll always have numerators and denominators that have the same degree. Remember, that's the highest exponent. And if they have the same degree, your horizontal asymptote will be the ratio of the leading coefficients. So there's a negative 1 in front of the x in the numerator. There's a positive 1 in front of the x in the denominator. Your horizontal asymptote is, you would have written like y equals a over c in algebra 2. So it'd be negative 1 over 1. Your horizontal asymptote is negative 1. So you should exclude that. It's just the ratio of the leading coefficients to your x's. Okay, and if you can just jot that down, I'm going to show you how it works on the inverse too. Okay, so -1 and 1 are the numbers we're looking at there. Let me scroll down to the bottom because those things should flip. What's your domain if you were going to, in a rational function? What value makes this denominator equal 0?
1.
-1. Wasn't that our range in the previous one? Yep, okay, so our domain is -infinity to -1 in union with -1 to infinity. And then if we were going to do the horizontal asymptote on this one, again, you'd look at the ratio of the leading coefficients. That would be -2/1, which is -2. Isn't that what we restricted from the domain? And that's our new range. So our range is that old domain. Okay, you have a homework assignment. You should work on the homework assignment for tomorrow. We're going to come tomorrow. We'll go over homework. We'll do some function aerobics. You'll get your test review for the weekend. Your test is next Tuesday. Don't wait to ask all your questions on Tuesday morning. You'll be stressed out, and that's not enough time. If you have quiz corrections you want to turn in, you can turn them in to me before we go. Otherwise, they're due tomorrow at the beginning of class.